All right. Today we're doing the spark on mosaics. Who knows what a mosaic is? If I say mosaic, do you know what that is? Violet does, and Lawrence does. So let me show you a picture. They've been around a long, long time. They're really old art form, actually. Used a lot in Islamic art, and they just used a lot. So let me get some pictures here. Some of the pictures are also not so great, depending on what you want to see. This one's really cool. I'll show you this one. You can do some really cool stuff with them. So can you see my mosaic here of this lady's face? And there's some other ones. There's a rooster and an apple. That one's paper. Someone actually cut all those pieces of paper. And you can do that too. And then you'll see things like this. This is a really old one. Really, really old mosaic. There's some other ones over here. And you'll also see them sometimes on the floor. And they can get really intricate. Here's another one. Isn't that awesome? I'm a big fan of mandalas. That's a mandala in the middle. I think they're really cool. And then that one you can tell. What are mosaics made of? Do you know from these pictures? Can you tell?
Glass or tile, I think.
Yeah, glass or tile. Or we make them from paper sometimes at home, right? This one's, you can tell, is a little bit more glass and glittery. They've got some fun ones. These are just showers. That's a cool shower. So, mosaics, there we go. Mosaics are made of little pieces, and they're an art form. Now, there's some mosaics where every piece is a square, and some mosaics where the pieces are all different shapes, but they're all tiny and they're put together. Kind of depends on what you want to do with it. Today, we're going to start out with mosaics that are square first. Little pieces of paper, or they can be big pieces of paper. You can use Post-it notes or whatever you would like to do and design a mosaic. So you draw a picture and you decide how you might want to fill that in. Let me show you. I have two other cool pictures for you. Well, I guess we'll talk about them. I'll show you one of them. I don't know how many of you are familiar with the county fair, the U.S. thing that we do of having a county fair. Whoops, this one. But this picture that I'm just about to show you, I took this picture this week when I went to our county fair where people enter different things to be judged, and they have a quilting contest as well, and they entered this one. And this one I wanted to show you because this is calculus. Did you know quilting could be calculus? It can. Any quilting, it could be geometry, calculus, algebra. You can look at it however you want. But this one in particular I loved because I don't know if I can zoom in on it. I can zoom in. Let's zoom in for you. Wow. Okay, there we go. You can see the individual squares of fabric that she's put together, but it makes a curve. I remember yesterday when we did our flip books, they're skinnier and then they get a little bit fatter, and then they go back down, and she's making a curve out of squares. So does this curve or does it not curve? Does it just look like it curves? What would you say? If you say this is a curve, raise your hand like this, thumbs up. Yeah? And if you say no, it's not a curve, just kind of looks like one, you can thumbs down. I don't really have an answer because how can we define whether it's a curve or not? It's kind of a blocky curve, but as I zoom back out on the picture, it starts to look more and more curved, doesn't it? It reminds me of pixels on a computer, which we'll talk about a little bit more too. So the idea of taking little parts and making a curve out of it and breaking things into smaller parts, that's a really fundamental idea in calculus. And that's what we're doing today. We're going to do mosaics. We're going to break a picture into little parts and build it out of those tiny parts. So you can think mosaics or you can think quilting, like this one, kind of whichever one you want. And I'm going to just let you guys, this one takes a little longer, I think, so 15, 20 minutes to do whatever mosaic you want. Especially if you haven't cut any paper yet, this one takes a while to cut up the papers. You can tear them. You can make them perfectly square. You can do whatever you want. You can make whatever picture you want. And it's just totally up to you. So it's your turn to start being an artist of the day. Any questions? Are you ready? Violet? You're really far from your microphone, so I know it's working, but I can't hear you.
You can use other
You could use little blocks if you have them. You can even use Legos, because Legos really, if you have Legos and you just build it flat, just one level, you're essentially doing a mosaic. So maybe you've done that, like you tried to make a face out of Legos or something.
I'll help you cut squares.
Okay, so you can do whatever you'd like. Or if you have help from a grown-up, you can fold the paper into strips and then whack, 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 and cut off little squares really fast. Some people have come to this class with tile kits. If you have dried beans in your house, you can just go grab a big handful of dried beans and glue those down. If that's faster. If you have the small size Post-it notes, you can do that. And that makes for some interesting discussions because they're kind of big. So whatever you've got.
No, I have these things that are like, they're kind of like, they work for mosaics.
Uh-huh.
Like magnets.
Oh, cool.
Shaped in blocks. So like.
Yeah, that'll work fine. You just want to stay one level because the mosaic doesn't go up or build like 3D. It's just 2D, huh? And Lawrence, your picture will have to be pretty big, won't it?
Should I use these?
Yeah, you can use whatever you have. As long as you stay 2D and you build it out of those parts. So some mosaics use teeny tiny pieces and some use really big ones. So you can do it whenever you've got at your house and whatever you want to do. So it's good either way. Yes, your name says Kelly. That's your mom. What's your name? You're unmuted. What's your question, bud?
Nothing.
Oh, you're okay?
Yeah.
Yeah? It's Lewis and Jamie. Okay.
Jamie.
Gonna rename you so I can write it. Okay.
Make sure you do it. Because yeah, there you go.
I'm ready.
You've already made one?
Yeah.
That's
It's out of Duplos, though, but it works. Yeah.
cool. Keep working on it. Or, oh, that's awesome. Is it a face?
Yeah, it's supposed to be a face anyway.
You can tell it's got eyes and it's got a mouth.
Yeah.
It's
Yeah.
kind of tricky with Legos, huh?
Yeah.
Big Legos. Okay, now make something else.
Okay.
Think of something else that you can make.
Do I make it out of squares or other shapes?
You can do whichever you would like. If you've got squares and that's easier, squares kind of have some unique challenges that are fun to learn about. But if that's too hard to make them right now, then you can do whatever you would like.
Got it.
Violet, are you done already?
Right now I'm working on making.
Aha! Well, those are magnetic. That's really fun. So you have a tree. Was it a little hard to make the circle look like a circle up there on the tree because you're using squares? Can you make squares look like a circle?
It was very hard.
It's tricky to get it the way you wanted it. Well, thank you for sharing it. It's a really pretty tree. You can keep adding to your tree if you want.
I'm almost done because I'm gonna finish making the second layer of it.
Shelley,
Yeah.
Arjun just asked me, is this really math?
Great question, Arjun. It really is math. Would you like to know a little bit about how it's math?
Yeah.
Okay. Do you remember we talked about calculus likes to break things apart, and it likes to make things into small pieces so it can measure? While you're making something, yeah, when you're building with pieces of pieces, remember the curve on my quilt that I showed the picture of? Were you in here when I showed the picture of the quilt?
Yes.
Okay. And we said, is it a curve or not? What if she wanted to make that quilt look really, really, really close to a curve? Would she use bigger pieces of fabric or smaller pieces of fabric? What do you think?
Smaller.
She would use smaller pieces? Why would she use smaller pieces?
So she could make the curve?
So she could make it curve. Have you ever tried, like Violet, she tried to make a round tree out of squares? And it's tricky to get a curve, isn't it? And we talked about on the very first day, we want to measure curvy shapes and we want to measure the curve of things flowing through the air. So to do that, we need to take really, really small pieces. And what the people who invented calculus did is they took pieces that were infinitely small. And then they argued for hundreds of years over whether that would actually work. But what you're doing in calculus when you get to the classes that they teach like in school or in a book is you're taking really small pieces and using that information to get really smooth curves. So it's an awesome question. Let me show you. If you look at this picture again, and I zoomed in to right about there, but what if I keep zooming in? Oops. What's going on?
It's getting less and less curve.
And can you see all the little tiny squares that my computer actually had to use to make the picture? Does anyone know what those are called?
No.
Computer word. They're called pixels. So see how this square, let me highlight here better. This blue square right here, it's actually not one color, is it? There's all these little squares and they're different colors. And I can zoom in even, I think, a tiny bit more. And so all these squares right here, well, now let's zoom back out. Let's zoom back out some more. See how they're getting smaller until pretty soon you're not going to even, you can't see the pixels anymore. Now it just looks like the fabric. So they're so small your eye can't see them individually and your eye makes a nice smooth picture. But everything that we do in technology, like what you're seeing me, I'm just pixels. But they're so small that it looks like a nice smooth curve. And those pixels are changing so fast, like we talked about yesterday, that it looks like my hand is moving. But you're really not seeing my moving hand. You're seeing a bunch of pixels change shape really fast. And they're really so small that it gives nice, smooth curves. That's why the question, is it a curve or not a curve, is kind of an interesting debate that scientists could continue to have if they wanted, because it looks curved to us. When does it become a curve? When does it not become a curve? Because if I zoom in, you can see all the teeny tiny parts. And that's where the math is hiding in this activity, Arjun. Making things into infinitely tinier parts. And then, who told the computer what color of pixel, what little tiny blocks to make me right now? And who told a TV how to send little tiny blocks so it would turn into a picture? And who told a computer how to make it look like your hair is moving in an animated movie? They have to do it with numbers and math and computer coding. So there's actually a lot of math hiding in what you're doing.
Thank you.
You're welcome. I'm really glad you asked. We were going to talk about it, but I'm really glad you asked instead, because that's even better. So one of the things that I love the most about this calculus class is that the grown-ups usually find out that they've been really good at math and they didn't know it. Because quilting and crafting are forms of taking something and making it 2D or 3D or 2D to 3D, like crochet or knitting takes a piece of string, and not only does it make it into a 2D, from that it makes it into a 3D something that you can wear, or taking fabric and turning it into a dress. And all of the thinking that's required of people who do a lot of handicraft is actually very mathematically minded and spatial reasoning, but it doesn't get a lot of credit as being math in America anyway. So to the grown-ups, while the kids are finishing, the more your children play with manipulating things like that, they really are gaining a really good foundation of math, and you can share with them the things that you like. That pottery, whatever, there's math hiding in all of it as we take things through dimensions. If you like to do pottery on a potter's wheel, you and a topologist would get along great, because topology is about stretching and moving lines to change them into different shapes. Mathematicians just like to describe what's happening in a way that anyone can understand, and they like to predict and use models. Artists aren't as worried about predicting it for someone else necessarily as they are about having a reaction to it or having an emotional response to what's going on. But you can have both. That's what's kind of fun about math, is you can have both. Does anyone else want to share? I think Violet's just going and going and going, which is awesome. Are you ready, Arjun? You going to show me your math? Well, you're muted. Do you want me to turn your mic on? Oh, your mom got it. Okay.
Almost ready.
Good job. So hard to do circles with squares, and you've done a nice job. Do you like it?
Yes.
Yes, it's bright. I love the color yellow.
It's supposed to be a face, so it's not done yet.
So you're working on making it into a face?
Yes.
What's the hardest part?
Putting the circle.
Getting it into a circle? Yeah, that can be tricky, huh? Thanks for showing it. You want to show yours again? Violet, you've got more on there. Go ahead. Talk really loud.
I need
Oh, we have the sun. You're working on the sky. It looks really nice. Thanks. And it looks like crystal. Oh, there we go. Gotta click a button and, sorry, get rid of something. There we go. Okay, Crystal's gonna show hers. Oh, pretty. You did every petal a different color. I love it. This doesn't surprise me, because you're a very detail-oriented girl. You like doing stuff and doing it really well, don't you? That's so pretty. What do you love about it? Do you love it? The colors? It makes me smile.
We did a lot of cutting. I helped her. And then my 3-year-old did this. I don't know if you can see it. We started
Oh, yay.
and we used little squares.
You're doing it too, down on the ground. Good for you. Harder to do with paper, huh, Crystal? Looks so pretty. Do you like mosaics? Think you have a new favorite craft, maybe? Maybe not.
It's certainly my favorite.
Is it? That's
I still have
awesome.
fond memories of grade school making mosaics.
Oh, fun. And you had no idea that it should have counted as math.
I could have gotten calculus credit for that.
That's right. At the very least, we should get credit for our understanding of the concepts. All right, Zahavia, let's see yours. Whoa, that's beautiful. Do you like it?
Yes.
I like the colors a lot. Did you enjoy making it?
Yes.
Is it kind of fun to make something out of all those little parts?
Mm-hmm. I think this.
It's very pretty. I
Thank
really like it. Thank you for showing us.
You're welcome.
Is there anyone else who's done and wants to share? Oh,
I don't know if you can.
are you
I
Minecrafting
don't
yours?
know if you can see. That one's a truck.
Oh, okay.
And then what else do we
No.
have? That one's it's upside down now, but it's a house with a chimney.
Aha.
And wrong way. And a car that's sideways now.
It keeps moving. That's very good, you guys. Did you like making them?
Did you like building them? She wants to know.
Yes.
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 Is it kind of tricky to make wheels out of squares?
No.
No. I like the
They
hook
look
cap.
like wheels. Our brain's pretty good at recognizing what the shape is meant to be, even if the edges are not smooth, isn't it? Our brains are pretty amazing. Thank you. Oh, I see Joe has his. Let me show Joe's.
It's a cherry blossom.
Ooh, the paper's really pretty. Yours even has some symmetry that kind of reminds me of a mandala, radial symmetry. I like that. Do you like it?
Mm-hmm.
Did you have fun making it?
Yeah.
Very nice. You need to keep that. Put it on your mom's fridge or wall. Let's see. Who else? I saw Crystal's and Joe's and Violet's and the Tates and Zahavia's. Oh, Lewis and Jamie, I haven't seen theirs. Or Lawrence's yet. Or Insha's. So you don't have to share. So if there's anyone else that wants to share, let me know. I see Insha now. Do you want to show yours? Are you still working? You're still taping. Okay. Lewis and Jamie, go ahead.
Unmute. Okay, you did.
Ooh.
It isn't done yet, but it's gonna be a smiley face.
No. Do you still have your other one, your bigger one that you made, or did you take it apart?
Oh, I have.
I took. Oh, Mom has it.
Will you have them both now?
Here, Rose.
Okay. Hold up that one and hold up your other one too at the same time if you can. Have your brother help you. Ooh, yours is getting curvy. Ah! Good job. Okay, can you hold up both of your smiley faces? Or Willie, do you have enough hands?
Lois, can you hold both the spots?
Sure.
1 second, Lawrence, and we'll look at yours, okay? All right, he's got it behind his brother's head.
Jamie, can you move your
They're
head?
both faces. Which one's easier to get your curve out of, the big ones or the little ones?
The little ones, definitely.
Definitely the little ones.
Yeah.
I'm so glad you did it that way because that's what we were talking about when Arjun said, where's the math? Zooming in on those smaller pieces, it's easier to make curves. And Jamie was making really neat curves with those tiny little tiles. And so that's a really great image of a face. You can do it. And then a face where it's a little bit more smooth and it's a little bit easier because he went to smaller pieces. Now, what if you can't go to smaller pieces? What if you're stuck with big pieces? and that's all you have, how could you make your curve more smooth?
Well, you could make like tons of them and in like the same curvy shape and then zoom out.
Kind of.
Yeah.
Yeah.
Back up so you can like your eyes can see them as one.
So if you get further away,
Yeah.
you'd have to get further away too. And what about if it's easier to use smaller pieces to make the same size shape? What if I'm stuck with the same size pieces? What do I have to do to the size of my shape?
You'll need to make your shape change. The shape of the pieces change.
Well, if I can't change the shape of my pieces, like those big Legos, I can't really break them apart. Do you have any idea how I could make? Lawrence is making something with big pieces. And so he's making it on the floor. And he's making a really big picture. Do you want to tell us about it, Lawrence? You're unmuted if you want to. Uh-huh.
It's the best I could do to make a circle.
So you're working on a circle. You think you, yeah, it's hard to make one, huh? Can you make a circle out of the white ones, do you think? Is that what you're working on now?
Yeah.
You think it will look more or less like a circle?
Probably more.
Do you have any more of the big pieces?
Yeah.
Yeah? What do you think you might be able to do to that big circle if you really wanted to make it look more like a circle? Still stumped? Okay, I have you on the big screen so everyone can see yours. Count how many pieces are in Lawrence's big circle. How many have you got there, Lawrence? Looks to me like you have 12, 13, 14, 15, 16, 17, 18. Do you have 18 pieces in that circle? Is that right?
I think 21, right?
21. 3 times 1, 2, 3. Oh yeah, 5. 15. So you have 21 squares up here. How many squares have you already used on your smaller one?
14.
You think you're going to end up using more squares in your white circle, your smaller circle?
Yeah.
Uh-huh. You're going to end up using more of them. If you have more of the big squares, you can make the circle bigger. And so that's the other connection to calculus. If I can't change the size of my shape, I can't change my Lego, then I have to make my picture a lot bigger to get a smooth curve. So if you're done making a mosaic and you want to try it, try to make a circle with big squares, like Post-it note size squares, and then try to make a circle. You don't even have to fill it in. You can just do the outline with little tiny pieces and see which one works better. But if you want to make a big circle and you only have big pieces, then you have to make your shape bigger. So the shape, the size of the shape and the size of the pieces, they kind of go together. Sometimes we call those ratios or proportions in math, or we can it's kind of scaling too. So there's all kinds of math hiding in there. Yeah, Lewis?
I finished my smiley face.
Oh, it's so cute. I love it.
I figured out how to make like a perfect circle.
Did you?
Yeah.
What'd you do?
So I put 3 pieces here and then 2 here, 1, 2 going down, 3, and then continue that for the whole circle.
So you have a pattern in that first quarter, and then you followed that pattern in each quarter of the circle, so it would be a circle and not a weird oval shape or something else?
Yeah.
Awesome. That's great. You're growing your math eyes. I love it. Arjun?
Oh. This is my face.
Oh, bring it over this way. Oh, very good. Hair and everything. I see the eyes and the nose and the mouth. Our brains are really good at telling that something is a face. Artists like to play on that ability quite a bit. Very nice. You've got good curves. Did you have fun finishing it off? Yeah?
Yes.
Where's
I
your
have
real
fun
face?
making the whole thing.
Oh, good. I'm glad. This is one of my favorite ones to do just because it's really fun to make mosaics, like some of your moms were saying. Say hello. This is my 2-year-old. Would you like to say hi? So I want to show you another example where math is hiding in handicrafts. This is from my own life. Just 1 second and I'll open the picture up for you. I made this a long time ago, about 20 years ago. Does anyone know what kind of craft this is? What they call it? You seen anything like it before? Lewis, what is it?
Needlepoint.
You could call it needlepoint. It's a specific kind called counted cross stitch. So there's nothing on the fabric, and then you have a pattern, and it uses little symbols to tell you what color to use. But every single one of, let's see if I can get my spot later. Everything back here in the mountains, the trees, and on this eagle, it's all made up of little tiny X's. And the smaller your X's, the more realistic your picture will look. And the bigger your X's, because there's different sizes of fabrics. This one's called a linen, so it's the smallest one you can do. If you use the bigger ones, then you can see the X's more. It's like how I zoomed in and out on the picture of the quilt. It's like seeing the pixels. It's harder to get circles looking like circles. But you learn some of the tricks that Lewis learned, how to make it look like a circle by having a pattern for each quarter as you go around. So I talk about this one a lot of times for a variety of reasons. You can see the curves. You can see they're not perfectly curved to our eye, but the colors will shade and blend, and it's all just made of X's. In fact, one day my, he was about 10-year-old, said, that's a painting. And I said, no, it's not a painting, it's made of X's. And they said, no, it's not, it's a painting. And I had to take it off the wall and say, it's made of X's, they're about this big, but it's made of X's. I don't think you could even see the X's if I zoomed in on it. I think it would just pixelate the picture, but we'll try. Let's see.
Mom.
Ah, there you go. Can you see? Now you can see all the different X's. So what I learned, and the reason I wanted to share this with you, is this is what I used to do a lot of times in high school. I would spend my free time. I loved having all this blending and shading of colors. I thought it was really fun and enjoyable, and I didn't think I was very good at math. But what I realized was I was really good at math. I just liked a certain kind of math. I actually really like calculus. But everyone thinks that calculus is so much harder than geometry or algebra. We teach it last. And it's not necessarily harder. It's just different. So what I want you guys to know is you're good at math. You're really good at math. You just may not know it yet. And that's really awesome. You're going to discover for yourself the parts of math that you really like. Okay? Is there anyone else that wants to share their mosaics? Arjun?
I wanted to just tell you something.
What would you like to say?
I knew that it was, I know math quite a lot.
You do?
Yeah, and actually, my mom told me before you said it's made out of wool.
Wood thread.
Very good.
Yeah, so now I know it's made out of.
Good job. It's made out of thread turned into X's, isn't it?
Can I show you mine?
Yeah, you can. You've been working. Oh, look at that. And now we've got all these different colors in the sky.
Black and a person and a tree.
And the tree and some flowers and grass. It's starting to look like a cross stitch would look, or a mosaic. It's beautiful, Violet. And I see Jamie's hand. Do you want to show yours? Ooh. That's a really fun free-form shape. Are you going to fill it all the way in, or are you going to just keep squiggling around? What do you think?
Keep squiggling around.
Keep squiggling around. I like how you just barely changed the color. That's really fun. All right. Guess what? We're done a little early, about 15 minutes early. I don't have anything else. Do you have more questions? Otherwise, I think you guys are all pretty motivated to keep tiling for the next little while. And you're welcome to make lots of mosaics as long as your mom or dad says it's okay. Are there any questions? Did I miss anyone that wanted to share? Okay, so explore different sizes and different things. You can share anything else that you do tomorrow when we start out. Oh, I see Lewis's hand. Go ahead, Lewis. I don't want to miss you.
I didn't finish this, but it was supposed to be like a big circle smiley face.
That's going to be really cool. You can still finish it because you've got little tiny tiles. So you're lucky. That's really nice that you have that tool to play with. Anyone else that I missed? Insha, I haven't seen yours, but you're still taping. Do you want to show what you have before we go? Okay.
If I fill this whole thing in, then it won't be.
Oh, wow. That's such a cool design. And I see some- What's your favorite part about it?
The body.
The body? It's really bright and happy and creative, and I like it a lot.
You want to make another?
Good work. Good work to all of you. You're all good artists and you're all good mathematicians. Who had fun today? Did you have fun? Oh, good. I'm glad. Zahabia, did you want to share something or say something? Go ahead. Oh, wow. So you tried it with different larger shapes as well. Very cool. Very fun. You know, the carpet you're sitting on is kind of the same thing. You're sitting on a rug that's got the same principles of math. You're sitting on math. That's really cool.
I have a question. I love the way you connected up, all the different art forms to math.
Uh-huh.
And, I sort of see how things like concepts working with squares and trying to get them to like through a circle.
Mm-hmm.
When using different kinds of shapes, could you just talk a little bit about, just to the kids about how that fits into the same conceptual model?
It was a little bit hard to hear all of what you said. So how using different shapes besides squares to model?
Yes.
And modeling different shapes with different things? Okay. The first thing that comes to mind is there's a really cool word I'll put in the chat box called tessellation. Squares tessellate, which means that if I ask you, I happen to have a playing card from my logic class. If I asked you to completely cover this shape up with squares and not leave anything showing, could you do it? Could you cover it all the way up and hide the whole Uno card with squares? Yeah. What if I asked you to put circles on it? Could you cover the whole Uno card with circles and not overlap the circles? Could you do that?
I don't think so.
There'd be those little funny shapes in between, huh? Circles do not tessellate, which means they don't like lock together and close the spaces like squares or rectangles do. So one of the things that you also, it's important in chemistry, it's important in art, it's also important in some structural things they're doing now, but tessellation would be, can I get it to work together? Now sometimes you can put shapes together in partnership and they'll tessellate. How many of you have a soccer ball? Yeah. Have you ever looked at what the shapes are on that soccer ball?
Pentagons.
Pentagons, and there's actually two shapes on there.
6 seconds.
I don't have mine in front of me, so forgive me if I'm wrong, but I'm pretty sure it's octagon or hexagons and pentagons. But if you cut open a soccer ball, thank you, Crystal, it's octagons and, or not octagons, hexagons and pentagons, right? I'm gonna make her video bigger so you can see it. If we try to make that flat though, guess what? Hexagons will tessellate, but pentagons won't. That only works on a curve. So if you have different shape blocks, some of you do, and you know the shapes, you can try seeing which ones tessellate or which ones need a partner shape to tessellate with them, or different kinds of patterns that you can make out of tessellations. So that's another angle on math with different shapes. And hexagons and octagons are really important shapes, especially octagons in nature. You can find octagons a lot in nature because they tessellate. Circles don't tessellate. So you can also kind of play around with that language and with those ideas too of what can I use to fill it in. So you won't see mosaics with circles very often unless you want that kind of non-tessellated look. If you want it to tessellate, you'll see triangles or squares or different things or a mix of them. Or you might see like a circle in the middle, but then you'll notice that everything, it'll go out in an array and you'll have to flip your triangles over and do it another way. So it's kind of fun. It's a great question. Thanks for asking.
Interesting.
So you guys can explore some more with, what if I wanted to fill that whole thing in and not have any gaps? What shapes do I need to use so that it will tessellate? And then there's regular tessellations and irregular tessellations too. You can Google images of those kinds of things and look at interesting pictures online as well. Usually those are stuff to do. Okay?
Thank you.
Thanks, everyone. So tomorrow's our last day. Can you believe it? And we're going to slice stuff. Have some, no, not done, you know, we're done tomorrow. Have some Play-Doh, if you've got Play-Doh or clay. You, rather than trying to slice up fruits and veggies at the computer, we will just use Play-Doh. And then we'll try fruits and veggies. You can try that on your own after. All right. Thanks, everyone. Have a good Thursday.
Bye.
We'll see you tomorrow.